Hi, this is Mr. Anderson. Today I'm going to give you a little podcast on scientific method. Scientific method is used by scientists, but it's also used by anybody who wants to understand how the world works. And so imagine we have a guy here. Let's make him kind of nerdy, so we'll give him some goggles. There we go. And he's wondering maybe, for example, what makes a rainbow work? Well, scientific method can be used to kind of answer that question. Or let's say he's daydreaming and wondering, let's say if I've got a plant that's growing in a pot and I play music for that, what kind of music is going to make that plant grow faster? And so to answer that question, you can use scientific method. And so maybe we'll think about this one right here. So first of all, we need a little bit of history. The history begins with Aristotle. And so there were a lot of philosophers back in the times of the Greeks. But the one that really applies to science is Aristotle. And here's a picture of him. This is actually his teacher. This would be Plato. And then this is Aristotle right here. I like this picture here because you can notice that this guy's kind of motioning upwards. Plato is talking about metaphysics and understanding how the world works just from this, thought, philosophical kind of a look. But Aristotle here has got his hand facing downwards, and what that implies is that he's looking at nature. In other words, in the natural sciences. Now, what did Aristotle use to answer all of these questions about how the world works? He used his brain, and he used intuition. And the good thing about that is that he was incredibly smart. We've found a lot of things that Aristotle speculated about have actually proven to be true, and we maybe didn't know it until maybe 100 years ago. And so really, really bright. The problem with that is that he was so bright that a lot of people after that never tested what he actually said. So an example, he said if you have a large object and a small object, and you drop both of those objects at the same time, the larger object is going to reach the ground first. And that was just kind of intuition for him. We now know that that's not true. So let's fast forward 1,000 years, or even more than that, and we go to this guy, Abu Ali al-Hassa, who was a Persian. He lived in modern-day Iraq, and he would be the first person to really develop, at least in history, to develop this scientific method. This is a quote: "Truth is sought for its own sake, and those who are engaged upon the quest for anything of its own sake are not interested in other things. Finding the truth is difficult, and the road to it is rough." And so we have this guy to thank for the word hypothesis and theory, and the idea that you, first of all, try to answer a question, and then you can prove if that answer is true. Wasn't a scientist, though, didn't really do experiments, and so then we have to fast forward a little bit to Galileo Galilei. Galileo Galilei lived in Italy. He, unlike Aristotle, always wanted to prove if it was right or not, and so he used the scientific method to answer questions. Example of questions, Aristotle, remember, said that large objects are going to fall faster than small objects, and it's really hard to see that. Imagine back in the time of Galileo, you don't have a motion sensor, you don't have a watch, and so it's hard to figure out which one's actually falling faster. So how do you do that? Well, one way to do it is actually to have an inclined plane, and if you have an inclined plane like this, you can time it, and you don't have to be so good on the timing. It's still gravity that is making this ball roll down the inclined plane, but he made these really detailed measurements, and he was able to determine that all objects fall at the same rate, which goes to that story of him dropping two weighted balls, which is probably true, from the top of this, the Leaning Tower of Pisa, and then showing that all objects fall at the same rate. A lot of those stories are they're just stories. But that's Galileo Galilei. The next person I want to fast forward to is a group of people, and those are the Mythbusters. And the reason I add the Mythbusters here, not because they're scientists, but they're modern day people using the scientific method. And so they'll answer many questions, but they answer those questions by developing first a hypothesis and then testing it. And they go out of their way to make sure that they're truly answering the question. So let's get into the scientific method. Scientific method was used by famous scientists. This one right here would be Isaac Newton. This one would be Charles Darwin. And this one right here was Niels Bohr. But they all use essentially this same method. And it always begins with a question. And so first of all, you start with what question do you want to answer? And so an example we could say right here is, let's say we have a plant, and that plant's growing. And we're going to play music for it, and we're going to play different types of music. And so maybe our question is, what type of music is actually going to make that plant grow best? So now we make a hypothesis. Maybe I'm of the mind that country music is going to make that plant grow fastest. And so that would be my hypothesis. Now we sometimes refer to as a hypothesis as an educated guess, but in scientists that's kind of a misnomer. It's not so much a guess as we know what's going to happen, we just have to prove it. Doesn't mean that our hypothesis is always correct, but we start with a hypothesis, which is this idea of what we think might happen. Next up is an independent variable, and so in an experiment the question will always tell you what the two variables are. And so listen carefully as I say that. I want to determine how the type of music affects plant growth. I don't know if you heard that, but there are two variables inside there. One was the type of music, and the other one is plant growth. And so if we go to independent variable, the way that I talk about this in class is the independent variable is the variable that I change. And so I change the independent variable. It's the one thing that I manipulate, and so that's that first variable in an experiment. The dependent variable then is a resulting variable. In other words, it results as an action of the independent variable. So if we go back to that question again, how does music affect plant growth? What's the independent variable? It's going to be the type of music that I play. What's the dependent variable? That's going to be plant growth. So what do we got down here? What are control variables? Those are everything that we keep the same. And so in this experiment, what are some things that we'd want to keep the same? Well, the species of plant would be one thing, maybe the amount of light it gets, the amount of water it gets, the nutrients it gets, the volume of the music, the amount of time that we play the music. And so those are all going to be the control variables, everything that we keep the same. And the trick is, if we don't control all the variables, in other words, if we have a few variables that change, not only the independent variable, then we can never know if we actually show that that independent variable has any effect on it. Okay, let's go to the next ones then. So what do we do next then? So this is a great picture right here. This is actually Einstein, and this in the background is another really famous astronomer. His name is Edwin Hubble, and so the Hubble Space Telescope is named after him. And what he was famous for was measuring the redshift in the universe, this idea that the universe is always expanding. Einstein doubted that and eventually said it was the biggest mistake that he ever made. So let's go to the next group then. What's a control group? So thinking back to that experiment with the plant, well, not only would we have one group that we are actually taking those plants and playing music for, but in a totally different room, we're going to have another group of plants, and those plants in the other room are going to receive no music at all. And so that the control group sometimes seems counterintuitive, but what is the control group? It's another group of plants that we're not exposing music to. Why would we do that? Well, we want to make sure that it's really the music that is affecting the plants, and it could be something else. And so if we see differences between these groups and the control group and the other one, then we can say that that's accounted to by the music. Next, we collect data. Data usually is collected in a data table, but it's always organized in a graph. When you do a graph, a thing to remember is that the independent variable will always go on the bottom, and the dependent variable is going to go on the side. If we're doing plant growth, maybe that's going to be a bar graph where we've got independent variable are the types of music, and we put those on the side, and the dependent variable is going to be amount of plant growth. Or maybe it's going to be a graph like this where we're changing something, maybe the volume of the music over time, and we're looking at plant growth. I should say plant growth, and we're getting a graph that maybe looks like that. It's getting a little bit messy. Okay, so what is our conclusion? Our conclusion is going to address that question. And so conclusion is looking back at the question and saying, hey, is our hypothesis correct or is it incorrect? The next thing you have to do as far as science goes is you have an obligation to publish the results of your experiment. And we do those in primary research. We do those, in some kind of a scientific journal. And so when Watson and Crick discovered the structure of DNA, the first thing they did is they wrote it up in an article in Nature. And what that allows other scientists to do is to repeat their experiment, and that's how science builds itself. And so if you've ever wondered how a science book is made, a science book is made by scientists. And those scientists collect data, and that science is tested by other scientists over and over and over again, and eventually we have a truth. And that's what science is, and it's a lot different from other disciplines that you have. The nice thing about science is that other scientists are always trying to prove other scientists wrong. And so by doing that, it's this wonderful check and balance, and we eventually arrive at this wonderful truth, thanks to the scientific method. So that's scientific method, and I hope that's helpful.